Hello and welcome to a nostalgic math chat with one of the clumsiest maths teachers alive. Today we are rambling about the department's paper 2 from May 2023. Okay, so let's get into it. It's giving analytical geometry. So straight away I'm thinking m is equal to tan theta is my shepherd, I shall not want. Okay, question 3. In the diagram, the equation of line AF is y is equal to negative x minus 11, okay, which they have filled in for us on the diagram as well. B, a point on the x-axis is the midpoint of the straight line joining A, whose coordinates are negative 1 and t, and C, whose coordinates we don't know. Okay, they've marked for us that AB and BC are the same length, so BE is the midpoint of AC. Cool. The angles of inclination of AF and AC are alpha and 63,43 degrees respectively, okay, which they've also marked for us on the diagram. AF cuts the x-axis in E. Okay, so E is a point on the x-axis, is the x-intercept of the line AF, okay. And D is a point such that DE is parallel to AC, which they also indicate for us with our little arrows. Awesome, okay. So, first question asks us to calculate the value of T. Okay, so straight away what stands out for me about the point A is that it lies on the line AF, whose equation has been given to us. So if we know the x coordinate is negative 1, then we just need to use the function to figure out the y coordinate, which is t. Okay, so let's do that. Woo. Right. So for 3.1.1, we are going to say t is equal to negative 1, which is our x, minus 11. So that is positive 1 minus 11, which gives us negative 10. So the value of t is negative 10. Oopsie. Okay, right. Then we're asked to figure out the size of alpha. Okay, so alpha is the angle of inclination for our line AF, and we've been given the equation of this line, which means we know what its gradient is. We know what m is. So we can use that to figure out what the angle of inclination is. So let's do another color. So 3.1.2, we're going to use the m is equal to tan theta relationship, right? So we know that our m is negative 1, and theta in this case is actually alpha, right? So in order to figure out what alpha is, we need to take the inverse. Well, interesting. So yeah, okay, I almost jumped right into that. Well, actually, interestingly, I wonder, inverse of, what's going on? Shift tan of negative 1. Okay, it gives you negative 45, so it gives you the angle in this quadrant, but you actually want the angle in this quadrant. That falls in that quadrant, so we need to be a bit smarter with our trig knowledge. Okay, so remember good old cast, right? So we know that tan is negative in the fourth quadrant and in the second quadrant, and we actually want the angle that is in the second quadrant, right? So we need to figure out which angle gives us a tan ratio of 1, and that we know is, well, which acute angle specifically, right? And that we kind of know is one of our special angles, is 45 degrees. And so therefore alpha will be equal to 180 degrees minus 45 degrees using our knowledge of reduction formulae, right? Right, so we know that these angles right? We know from our reduction formulae that these angles are related. They all have the same tan ratio or the same sine ratio, the same cosine ratio. The only difference will be the signs. In some quadrants it's positive, in some quadrants it's negative. Okay, cool. So that being said, right, we now know that our alpha is 135 degrees. Perfect. Then the last question asks us to find the gradient of AC to the nearest whole number. So we're just using the relationship, the angle of inclination relationship in the other direction. So for the second question, we knew what the gradient was. We need to figure out the angle. But now we know what the angle is, so we need to figure out the gradient. So 3.1.3 m is equal to tan 63,43 degrees. And let's see what that gives us. Tan, oh, am I even in the right? Yay, what does this mean now? Am I in degree mode? Am I in radian mode? What's going on? I don't know. Let's see what we get. Ooh. Okay, let's test with one that we do know. What is tan of 45? Okay, no, we're definitely not in the right mode. Okay, yeah, that's the right mode. Okay, so now we can... Okay, so that's 1,99956. So that's roughly... Oh, and we're told to give it to the nearest whole number. Nice. So m is approximately 2. Okay, so I'm just going to pause here and just check that I'm in line with the memo so far. So first answer, t is equal to -10. Second answer, alpha is equal to 135 degrees. And third answer, the gradient is equal to 2. Cool. Righty doos. So let's move on to the next question. I'm just going to fill in what we found out on the last. So we found out that t is equal to not +10, -10. We found out that alpha is 135 degrees, and we found out that the gradient of this line is, we're going to use 2. Okay, right. So determine the equation of AC in the form y is equal to mx plus k. Okay, so we know that its gradient is 2, well, we're just going with 2, and then we have a point on the line which we can sub in to figure out what k is. So we have -10 is equal to 2 times -1 plus k. So -10 is equal to -2 plus k. So -8 is equal to k. So the equation of the line will be y is equal to 2x minus 8. Okay, do we agree, Memo? We do indeed. Right, okay, so this is easy going so far. Like I said in a video a while ago, sometimes I just look, so how I choose the questions is I just kind of like take a quick glimpse and I see if I can immediately solve the question, then I don't deem it as level 3 or 4. But if I look at it and I'm like, ooh, there's just an extra notch of thinking that I needed to do, then I do a video about it. Sometimes in doing the question, I then figure out that actually this is actually quite standard. But anyway, let's see how the rest of it goes. So what do we now know? We know alpha is 135 degrees. We know that t is equal to -10. We know that the equation of this line is equal to y is equal to 2x minus 8. Okay, so that's all we found out so far. Right, so we are asked to work out the coordinates of C. Very interesting. Very, very interesting. How would we do that? Okay, so I think there's a couple of ways of doing that. So what immediately comes to mind for me is, because we know that AB is equal to BC, right? Then what is also true, and because they share gradient, right? Like it's a straight line, so AB and BC both have the same gradient. So the amount of run and rise that I need to do from A to B is going to be the same as the run and rise that I need to do from B to C. So I'm going to figure out, okay, to go from, okay, so this is meaty. We don't know what the x coordinate of B is. We just know its y coordinate is 0. So we need to figure out the x coordinate of B, and we do that by remembering that B is the x-intercept on the line y is equal to 2x minus 8. So I'm going to put in 0. Okay, so let's just see what we're doing. Work out the x coordinate of B. So we're going to do that by saying, okay, when y is equal to 0, what is x? And we can either see just from inspection that x is equal to 4, or you can go through the whole spiel of making x the subject of the equation, right? So that means the coordinates of B are 4 and 0. Okay, so now to go from point A to B, we need to go across by 5 units, right? To go from -1 to +4. And then we need to go up from -10 to 0. So that is, we go up 10 units. Okay, so then we're going to replicate that as well to go from B to C. So we're going to go this way by 5 units, and then we're going to go up by 10 units. Okay, so the coordinates of CEE is going to be, starting from 4, we move right by 5 units, and starting from 0, we move up by 10 units. And so that means C's coordinates are 9 and 10. Okay, and if you put that into this equation, it should work out. So 2 times 9 is 18, minus 8 does in fact give us 10. So if we found a point that didn't satisfy that equation, then we'd know that we definitely haven't found the correct coordinates for C. Okay, cool. So now we've got the coordinates of C. Then we're asked to determine the size of FED. So this angle, oh my goodness, this angle over here. Okay, how shall we do that? It feels like the parallel lines, just because the angle is neighboring one of the arms of the angle is one of the parallel lines. So it feels like that might come into it somehow, somewhere. So I mean, we know that this angle over here is 45 degrees because angle's on a straight line. Yeah, and likewise this one because vertically opposite angles. And then what else do we know? Oh, okay, so again with vertically opposite angles, we know that this is 63,43 degrees. So then that allows us to work out this because angles in a triangle, and then that allows us to figure out what AED is, which allows us to figure out what that is. Okay, that might have been a very long-winded route, but it got us to our destination. Okay, so we don't actually even need this one to start off with. Oopsie. Right? Because we can just use angles on a straight line over here, and then we can get this angle because vertically opposite, then we can get this angle, and then we can get that angle, and then we can get sorry, I just got lost for a second there. Yeah, then we can get that angle. And we do need that angle. Okay, cool. So we are going to explain how we got this one first, then we're going to explain that one, then we're going to explain that one, then it will give us this one, which will give us this one, and then we can explain where we got this one, and then we have FED. Okay, or actually we don't even need, right, because we could just say angles on this straight line, right? If we have, oopsie, if we have this angle, then FED will just be 180 minus that. Okay, so that's what we need to do. Okay, let's do it. So, different color for morale. 3.3.2. Important thing here is reasons all the way. Okay, so angle BEA, right? So that's this angle is equal to 180 degrees minus alpha, right? So 180 degrees minus 135 degrees, which is equal to 45 degrees, right? And the reason is angles on straight line AF. Okay, so that's this line over here. Righty doos. Then, so we've got that one now. Then the next one we need to talk about is angle OBA. So that's this angle over here is equal to 63,43 degrees. And that's because they are vertically opposite angles. Okay, then next up we need to figure out, so that one's done. So now we need to talk about this angle. So angle A is equal to 180 degrees minus 45 degrees plus 63,43 degrees, and that is because angle sum of triangle EBA, right? So that is 180 minus 45 and 63.43. So that gives us 71,57 degrees. Whoopsie. Okay. Right, so now we've got that one. And then we said by getting that one, we'd use alternate angles to get this guy. So that is angle DEA will be equal to angle A, which is equal to 71,57 degrees. And that's because of alternate angles on, well, specifically which parallel lines. DE is parallel to AB. Okay, right, getting there. So now we can figure out FED. Okay, so angle FED is then equal to 180 minus angle DEA, right? And that's because angles on straight line FEA, right, or just FA, that's fine. So that is 180 degrees minus 71,57, and that gives us 108,43, I think. Let's double check that. Oopsie. 180 minus 71.57. 180. Okay. Right. And we could also, yeah, no, I don't know what I was trying to, well, I was going to talk about exterior angle of a triangle, but that actually wouldn't have helped us. Oh, it would have helped us. No, it wouldn't have helped us. Okay, never mind. So did we finally get our answer? Yes, we wanted the size of FED, which is 108,43 degrees. Okay, let's see what the memo has to say for itself. So we have the coordinates of C are 9 and 10. Yes, indeed. And then for the second question we have FED is 108.43 degrees. Yes, indeed. Right. Last question. So I'm just going to start by filling in everything we know. Okay, maybe not everything, but some of everything. Okay, I think that's, yeah, this is just about all the stuff we filled in so far. Okay, so G is a point such that E, A, G, C, in that order, even if they don't tell you in that order, it is in that order, is a parallelogram. Okay, so whenever we name our quadrilaterals, we always follow the order of the vertices. Okay, so E, A, G, C is a parallelogram. Determine the equation of a circle centered at G and passing through the point B. Wow, okay, this is quite rich. Okay, so let's first draw this parallelogram for ourselves. So E, A, okay, and then the C will connect back to the E. Why don't it make the nice straight line for me there? Anyway, okay, so G is gonna be somewhere here. Right. Okay, so G is going to be over here somewhere. So we need to figure out the coordinates of G so that we know the center of the circle that we're going to draw, because the circle is centered at G. And in order to do that, we're going to do the rise and run, right? Because we know that for a parallelogram, EC and AG are equal in length, first of all, and they are parallel, second of all, right? So they're equal in length and they're parallel. So therefore, whatever rise and run I do to get from E to C is the same rise and run I'll have to do to get from A to G. Okay, so let's do that. Right, so to go from E to C, okay, I'm going to need to move. Oh, we don't know what the coordinates of E are. Okay, I guess it's easy enough to find out. Is it? Feels like a lot of work. Okay, first of all, I'm just gonna erase this because it's just feeling like too much. And I don't think we need all of this. So I'm also going to erase it because it feels like too much. We'll fill it in again if the hour requires it. Okay, so let me draw my parallelogram again. So E, A, G, C. Okay, right. So I don't know what the coordinates of E are. I don't know what the straight line. Oh, we do. We have the equation of the straight line. Okay, so I'm going to start by figuring out the X. Hey, the coordinates of E. Okay, so E is a x-intercept, so I'm going to find its coordinates by making y equal to 0. So then we have that. So 11 is equal to, well, okay, I guess we could move the x over. So positive x is equal to negative 11. Okay, so therefore the coordinates of E are negative 11, 0. Okay, so negative 11, 0. So then to go from E to C, I'm going to need to run 20 units, right? To go from negative 11 to positive 9, that's 20 steps. And then to go from the y coordinate 0 to y coordinate 10, I'm going to need to go up by 10 units. So then I'm going to do the same to go from A to G. So from A to G, we're going to need to do 20 steps horizontally, and then from there we're going to need to go up by 10 units. Okay, so the coordinates of G, oopsie daisy, coordinates of G is going to be the x coordinate of A plus 20 steps, and then the y coordinate of A plus 10 steps, right? So that's going to be positive 19 and 0. So G actually lies on the x-axis in an interesting plot twist, right? So those are the coordinates of G, and that is the center of the circle. Okay, so then we know that our equation for this circle is going to be x minus 19 squared plus y minus 0 squared, which is just y squared, is equal to r squared. Okay, we don't know the length of the radius. Okay, we are told that the circle passes through the point B. So in fact, I'm actually just gonna quickly adjust my diagram to fit expectations. So our G is actually, so if we just extend our x-axis a bit, our G is maybe like somewhere here, right? Okay, terrible parallelogram, but you know, imagination, life is your creation. Right, so our 10, just gonna move that here. Okay, and if you go to a maths exam with coloring pencils, you'll have so much fun, I promise you. Right, okay, so this is our G. Oops, and we left the coordinates behind. There we go. Right, so we can see that B and G are on the same line. Wait, and first of all, why is this relevant? It's relevant because we've been told that our circle is centered at G and it goes through B, so it's going to look something like, it definitely won't look something like that, but you know, we get the idea. Okay, so that means this over here is a radius, right, to go from the center to one of the points. So we don't even need to use the distance formula because they're on the same horizontal line. So we can just say here BG is a radius of the circle. Okay, and so we can use that knowledge to say, okay, therefore R is equal to 19 minus 4. How many steps did I need to make to get from B to the center? I need to make 15 steps. And so our equation in all its glory for this circle is going to be x minus 19 squared plus y squared is equal to 15 squared, right? And more simplified, x minus 19 squared plus y squared is equal to 225. Okay, let's see what the memo says. So the memo says yes, she agrees. Awesome stuff.